Okay, hello, my name is Young, and I'll be your host for today's webinar on Kubernetes networking and security with Rancher Labs and NeuVector. Today, our first presenter will be Rancher Labs Principal Engineer Murali Paluru. Up next, we'll have our NeuVector's CEO and co-founder Fei Huang. Towards the end of the presentation, there will be 10 minutes for Q&A. So I'll go ahead and hand this off to Murali to start.
Can you guys see my screen?
Yes.
Okay. Hey, good morning, everyone. So my name is Murali Paluru. I work at Rancher Labs as a principal software engineer. So in today's webinar, I will be talking about Kubernetes networking. And in the later half of the presentation, Faye will talk about security aspect of things in Kubernetes. So in today's agenda, I would like to briefly talk about, what is the difference between Docker networking versus Kubernetes world, and then go into more details about the various concepts of the Kubernetes networking. And I will talk about how the various network plugins are used in Kubernetes clusters for cross-host communication. So here I have a slide which kind of is talking about the differences between Docker versus Kubernetes. So let me break this down here. So if we start on the left hand side of this of the screen, so I've got two nodes which are running Docker, and on node 1 here we can see there is a Docker 0 bridge, and we can see the IP address for that, and there is a container A. For this example, I have a web application running inside container A, and it's providing the web service on port 8080, and we can see the Docker IP address as well, 172.17.02. So when in a similar way, we have container B on node 2, which is a database container exposing its service on port 3000. So now when these two containers want to talk to each other, here we can see the problem immediately, that the IP addresses are not unique, and you can't communicate with each other. So what we do is we publish the port. So here at the bottom half of the screen, we can see the host IP colon port 80. So that is the publish port for web application container. And on the node 2, we have the publish port as 9000. So using publish ports, Docker containers talk to each other. So this is one way of doing Docker networking. But the main point is, generally the Docker 0 bridge and the subnet used for Docker 0 bridge is the same. Whereas in Kubernetes, what happens is, the bridge to which the containers are running are attached, they use their own subnet. So here in this example, the node 1 on the Kubernetes side has the Docker 0 bridge, but it has a different subnet, 1042.1.1/16, and on node 2 it's a different subnet, 1042.2.16. So this is the main difference between Docker networking versus Kubernetes. In Kubernetes, each node gets its own subnet, and all container IP addresses are unique. So if the web app and the database wants to talk to each other, they use the IP addresses directly. There is no concept of publish port, or there's no confusion of any sort. So that's the main difference between Docker versus Kubernetes networking. So let's move on to some of the concepts of networking. Now, before we jump into the actual networking stuff, I just want to talk about what a pod is from the perspective of networking. So, this is like there's a huge discussion about what a pod is. There are a lot of tutorials and stuff. My understanding in terms of networking, a pod is two or more containers running together as a group. So in a pod, usually there is a pause container. So plus the actual containers. So the pause container brings the network namespace to the table. And this network namespace is used by the actual containers for the various communications. So if I have to explain this in the Docker equivalent, the first step that you would do is, Docker run -- name pause. So this is the pause container. You could use whatever image you want. For example, here I'm using Ubuntu and I'm doing Sleep Infinity. So this one, what happens is you just start a pause container. It's just doing nothing. It's idling there. Now, in the second Docker run command, we run the actual app, and here we can see -- net container equal to pause. So that means you are using the network namespace of the pause container. So this is what's happening underneath, when we launch a pod. When pods are launched, as I mentioned in the first discussion, each node in a Kubernetes cluster gets its own subnet. Now, this whole subnet is part of a bigger subnet, and that is called as the pod network seeder. So it could be whatever the cluster admin wants it to be. For example, I could choose 10.42.00/16. So we have like 65,000 plus IP addresses. Now, how do we, split this into smaller chunks for use into each node? It depends on, again, the cluster admin. I could, if I plan on running, more containers on each node, I would split it as /24. If I want to support more nodes and less containers, I would use a /25. So here we can see in strategy 1, you can have up to 256 nodes and 256 containers on each node. Whereas in the second strategy, I could go all the way up to 512 nodes and 128 nodes containers per node. So this is configurable. The important point here is this pod network seeder should not overlap with any of the network seeders on the host. That is the most important thing. Otherwise, the routing and every other aspect of networking just breaks. So cluster IP, in Kubernetes, all pods are ephemeral. What that means is, most of the pods are short-lived. They are throwaway containers kind of a thing. So what happens in this context is the pods can change IP addresses very quickly. Now, if some service is trying to rely on this pod's IP address, it would be very hard to keep track of it. So for this reason, Kubernetes has this indirection concept called cluster IP to reach the actual containers. So it actually provides a nice functionality. What it does is it hides the actual pod IPs. So that way, all the scale up, scale down scenarios, the failure scenarios, the restarts are all, abstracted or all hidden away from the end user who's using the service. Any microservice, it uses this cluster IP. And one interesting aspect of this is, even though there is an IP address, there is no physical network interface associated with this cluster IP. All of this is completely virtual and implemented using IP tables. Now, this service IP also has to come from certain subnet, right? So that subnet is called the service/cluster IP range. Very similar to the pod seeder, it has to be non-overlapping with the host network. And this could be also configurable. It could be pretty big, but it could be much smaller than pod seeder. So what drives the size of the subnet is the admin. It is decided upon the admin. How many services do I need to run in this cluster? Based on that, one would choose the service subnet. In Kubernetes, the interesting thing is, when these services are running in a cluster, they are discoverable to each other by certain conventions. Now, if excuse me, if there are two services running in the same namespace, you could just use their names, service names to talk to them. But if they're across a different namespace, so you just append the namespace name to the service name. So here you could say, like, for example, if it is a web app and it's in a namespace called ns1, you would just say webapp.ns1. And the default domain that is used in this DNS is cluster.local. Again, this is also configurable. The component that is responsible for providing this service discovery functionality in a Kubernetes cluster is called kubedns. Now, this kubedns is also a service. and it is backed by n number of pods. It could be 1 pod or 10 pods. So it all depends on the needs of the user and the demands of the cluster. So it's completely scalable. So as we talked earlier, the service IP abstracts the scaling up and down of these pods. So the kubedns is scalable dynamically. Okay, host port. In the first earlier discussion, we talked about the Docker's publish port, right? That's the way how you expose the containers to the outside world. So in Kubernetes cluster, what happens is all the containers, all the pods are part of the overlay network. Now, these pods are not reachable to the outside network. To expose these pods to the outside network, there are multiple concepts. One of the concepts is host ports. So this is exactly the equivalent of the expose port in the Docker world. And this is not the recommended approach. It's there for historic reasons. For users who are just starting to use Kubernetes, they want to have a similar functionality or similar approach for exposing their services. They could use host port, but this is not the recommended way. Instead, there is a concept called node port. So this is the recommended way of exposing the services in a Kubernetes cluster. So it's very similar to the expose port, but the only difference is instead of exposing or publishing the port on a single node, that port is reserved on all the nodes in the cluster. So why would somebody need this, right? Now, as I mentioned earlier, the pods are ephemeral. Now, let's say you have node 1 and node 2. Now, if a pod is running on node 1 and for some reason node 1 crashed, now the pod would move to node 2. Earlier, let's say on the node 1, you were exposing your service on port 3000. Now, when the pod moved to node 2, if the port 3000 is taken away by some other pod, then this new pod that moved cannot start because the port is not available. To handle this scenario, this node port concept was introduced. So this is very similar to the expose port or the host port, but this is the recommended way. It just reserves the port on all the nodes. Now let's talk about the network plugins, right? So in Kubernetes clusters, there are multiple nodes. Now these nodes need to communicate with each other, and the pods running on these different nodes need to communicate with each other. To make this cross communication happen, there are multiple network plugins available out there. Now, how does Kubernetes work with different vendors' network plugins? So it works based on a standard. So it's the standard is called CNI. It's a short form for Container Network Interface. So all the different vendors, they write their network plugins adhering to this standard, and that makes it possible to work in any Kubernetes cluster. So what is the impact of using a CNI plugin on Docker CLI? So the CNI plugins, most of the time what they do is they bypass the Docker networking. So for that reason, they use a --net equal to none. And then later, once the container starts, they inject the network namespace into this container. And for this reason, what happens is when a user says Docker inspect and the container ID, you won't be able to find the network information. So that's the only drawback. It's more of a small user experience problem, but there are other ways to find out the container or the pod IP addresses using kubectl command. And the network plugins can be broadly classified into two different kinds. One is the overlay kinds, and the other one is non-overlay. When I talk about overlay, what happens is, whatever might be the underlying network topology or the network setup, you run on top of that. So that's the overlay. What the advantage of this is, this is like, you don't have to worry about how your underlying network works. It works on most of the cloud providers, and it's easy to set up. The only downside of overlay options is, there is a little bit of overhead in terms of network usage. Like, there are certain bytes, certain number of bytes that are needed for overlay networking to happen. So that's the overhead. Whereas in non-overlay options, you would have the pods talking to each other without any overlay. So that means they're like directly routable or they're directly connected, stuff. So this kind of requires a special setup. So this would not be available on all the cloud providers. It depends, and also it needs custom configuration as well. But some people prefer to use non-overlay options mainly in their private data centers because they have control over their network, and also the main reason being, they have some applications where they cannot afford any kind of overhead, network overhead. So it's in like special cases, the non-overlay options are used. Now, some of the examples of this network plugins are Canal. So Flannel is one of the most popular backends. It is, it supports multiple backends. It supports both overlay and non-overlay options. Some of the most popular backends are like VXLAN and IPsec. So now this VXLAN is used in most cloud environments, and it's used in an environment where your underlying network is either private or it is pretty secure. For example, if you are running in AWS, if your Kubernetes cluster is using a VPC and all the IP addresses are private and you have proper firewalls, then you would use VXLAN. So what happens is when the traffic is encapsulated using VXLAN and it is sent from one node to the other, when the traffic is going on the wire, it is in clear text, like there is no encryption. So this is acceptable if it is a private network, right? So but it doesn't work out if it's a public cloud. Now imagine you have a Kubernetes cluster, one of your node is coming from AWS, the other one is coming from GCE, let's say. Now you have traffic going over the internet, public internet, and clear text. This is not safe, right? So for this reason, one would go with IPsec backend. So in this case, as soon as the traffic is exiting a node in a cluster, it gets automatically encrypted. So this is perfect for running in public cloud. Now in the non-overlay options, we have host gateway. So in this, what happens is the routes are programmed on the node itself for different cluster seeders. So this is kind of cloud agnostic. You just program the routes and things start working. But at the same time, there might be a little bit of config that is needed depending on the cloud provider. This one provides a better performance than the overlay options. Now there is another backend called AWS VPC. So this is specific to AWS, very similar to host gateway, but it is very specific to AWS cloud. It just like non-overlay, any other non-overlay options, it provides better performance as there is no network overhead. Now this Flannel, out of the box, it doesn't have any kind of a network policy support. In Kubernetes, one could program network policies. Just like many other things, you need a controller to actually, enforce these policies. So Flannel doesn't have the enforcing or the controller component to take care of the network policies. So so Flannel is like is a pure networking solution. It's like battle tested in many production environments, and it's used by a lot of our customers as well. Here is a kind of an overview of how the VXLAN backend of Flannel works. So let me go over this picture slowly. So I have three different nodes: node 1, node 2, and node 3. On node 1, you can see the IP address of the node configured at the bottom, like each 0. Similarly for node 2, similarly for node 3. And on node 1, we have this CBR0 bridge. You can see this box, and it has its own subnet 1042.1.1/24. Similarly on node 2, we can see 1042.2.1/24. Similarly on node 3, 1042.3.1/24. So here we can see the subnet allocated to each node is unique, and the containers that are connected to this CBR0 bridge on each node have unique IP addresses. So for example, on node 1, I have 1042.1.2 IP address for one of the containers. And on each node, we can also see that there is a flannel interface. Now, this flannel interface is the key for the VXLAN encapsulation. So now what happens is, now let's say the container here on node 1 is trying to talk to the container in node 2. Now 1042.1.2 is trying to talk to 1042.2.2. Now the packet hits the CBR0 bridge, and then the CBR0 bridge, it forwards it to the flannel interface, and from flannel, using the help of the IP table rules, it encapsulates this packet and sends it over ETH0, which is the Ethernet 0 interface of the node 1, puts it out on the wire, and it reaches the node 2, and then from ETH0, the packet goes through the IP table rules. It gets decapsulated, and then goes through the flannel interface, and it hits the CBR0, and finally the packet reaches the actual container. So that's the packet flow of the using a VXLAN backend of the flannel plugin. Now, in a host gateway backend, here we can see there is no flannel interface because you don't need any encapsulation. The packet just goes on the wire directly. So what happens here is, when the packet going from the container 1042.1.2, it hits the CBR0 bridge, and it goes via the ETH0 directly. So here what happens is that the source IP address of the packet is directly the container's IP address, and the destination IP is also directly the destination IP, which is 1042.2.2. So this is the non-overlay option. So this one, because there is no encapsulation involved, it provides a much better performance than the VXLAN backend. Now, one of the main reasons this Calico plugin is popular is for the layer 3 routing capability. So in the earlier case, what we saw is the VXLAN backend and the non-overlay option of a host gateway, they are like on a L2 network. Now in a layer 3, the pods are routable, so that is the main advantage of using Calico. And there could be some deployments where you have an existing services in your infrastructure that you want to expose to the new services running inside the pods directly. So this would be a perfect use case to use Calico for layer 3, and also the BGP route reflecting capabilities as well. So Calico supports both non-overlay as well as the overlay options, and for the overlay, Calico uses IP in IP encapsulation, and as it is with any other non-encrypting encapsulation, this should be used only on like a private or a secure network. Now Calico has the components that are needed to support network policy. So that's the cool thing. It's Calico comes with both the network plugin as well as the network policy component to enforce these network policy rules. There is another popular plugin called Canal. So what happened was, not a lot of people wanted layer 3 routing. They wanted all the good things about flannel, but at the same time, they wanted the good things provided by Calico in terms of network policy. So they built this plugin. So it's literally take flannel and take the network policy component of Calico and piece them together. So that's Canal networking plugin. So this is how the various network plugins work in Kubernetes cluster. So these are some of the things that I wanted to share today. Thank you for this opportunity. So I pass on the ball now to Fei, who will talk more about security.
Thanks, Murali. Thanks, everyone. Let me share my application first. Can you see my screen?
Not yet,
Not
Fei.
yet. Let me try again.
Okay.
Okay.
Looks like I can see it, Fei.
Cool.
Nice.
So thanks again, everyone. Oh, I think it's okay. So today I'm going to talk about the Kubernetes Security Mesh. Also going to talk about several real security cases we see in the field, in our customers, and in our AWS honeypot environment. So before we talk about Kubernetes security, we want to look this issue from a security angle, see what are the changes which can impact the security, what are the challenges came from Kubernetes deployment and automation. So one big, those are things that Kubernetes changed the whole workload in the cloud. One is the hyperscale become possible, and that is the big change is from network side, a lot of east-west traffic become explosion in this new microservice platforms, because it's not like a monolithic old application. You have a lot of process communications. Now suddenly everything become small services and sits on top of virtual networking. So you will see tons of network interfaces and tons of traffics flowing internally. That's a pretty big change. And then the issue came from this new deployment is, the traditional tools you have to have a good visibility, suddenly you lose a good detailed views. Like if you have hundreds of pods, they keep changing, keep scaling, then how can you have good visibility on that? Visibility is not only for the management purpose, it's also critical for security, right? Because you have to see what you want to secure. That's another challenge. And because this whole Kubernetes open source are based on a lot of open source libraries, we all know that the good side of open sources, and also some challenges came from open sources, which is you see a lot of vulnerabilities was built in by open sources, and you cannot fix all of them efficiently. That's another issue, different from the old days of service deployment. Then from the security angle, all the network attacks, insider attacks, those runtime security challenges are still happening. Doesn't matter you load this container or you load this as a virtual machine services. So the same attack still go into your network, still gonna addressing your services, even it's become a Kubernetes pod. So all those big changes bring the new challenges to the security. So we believe to make the security work in this hyper dynamic, virtualized environment, and you really need the automation for this security work. So because of this reason, NeuVector invented we call Kubernetes Security Mesh. So security mesh, think about this as a layer of security to protect all your workloads and microservices on top of Kubernetes. Think that's a layer dedicated to protecting your infrastructure, and highly focus on the application and the data, because that's the most important assets that your company, enterprise is going to own. Because with more and more people go to public cloud, cross clouds, even private clouds, all the infrastructure as dedicated infrastructure, and you may or may not own that base layer at all. What you own is your workload and your Kubernetes, your applications containers, and those are really the assets you want to protect. So that's why NeuVector have a security mesh concept. So you can deploy on top of the base layer, provide a deep application awareness and the deep application security. I'll explain how to do that. Before I drill into the details, I want to tell several interesting use cases we see. First one, I think maybe most of you already heard about that. A couple of months ago, Tesla trying to open Kubernetes management console port to the public internet. They just enabled the firewall port, but unfortunately, the IT admin forgot to set the strong password. It's still using the weak default password. Then this issue was quickly identified by some hackers because they just use regular port scanning. They can find this Tesla's Kubernetes console was open to public, and they log in with just default password. And then when they get in, they see they browse around. They see there's AWS storage secrets was configured in the Kubernetes. Obviously, hacker can use that secrets to access Tesla's sensitive information already. There's no proof that those information got leaked or not, but we all know this could happen easily because they have the secrets there. And then the interesting enough thing is this time the hacker didn't do the traditional way of bad things. They actually trying to leverage the Kubernetes platform. They deployed some crypto mining containers, pods in the environment. So they try to use Tesla's resource to do the crypto mining for them. And it's smart enough, they actually try all kinds of ways to hide their crypto mining pod from being recognized by an administrator. For example, they use techniques like they use a non-standard port, which was not obviously for the gateway firewalls, and they use they hide their real IP behind the Cloudflare CDN, and they also encrypt the encryption and the proxy mode of the Kubernetes networking. By this way, the gateway firewall just didn't know anything about that, right? It's purely hidden in the environment. Also, they also try to, because it's containers, they try to configure the port resource usage limit. For example, 5% of the CPU, maybe 10% of the memory. By this way, those small crypto mining containers are deeply hidden in the environment. Think about you have hundreds of thousands of containers under management of this Kubernetes. You won't realize there are 2 or 3 bad containers doing crypto mining silently. That's why it took Tesla, I think, more than a couple of months to realize this issue. And then they don't even know when this was happening. So that's really bad. So start from 2018, we see crypto mining incidents are happening a lot. Some reports says there are 6 times more every quarter. So this has really become more and more serious issue for a lot of enterprises if you manage Kubernetes, especially in the public cloud environment. So there's another interesting use case that I want to share is we have AWS honeypot system running there with NeuVector system and some demo containers running all the time for more than a year already. And we see all kinds of attack almost every couple of days. And this happens, I think, maybe also two or 3 months ago. We see the real Mushtik botnet was hacked into one of our honeypot container. And what we see that is we load a vulnerable WordPress container in the honeypot by purpose because we want to trap those hackers. And we see someday we see a IP address from France. It gets into this WordPress. It uses port scanning, figure out, oh, this is WordPress container, and this is an old version. So they they run a malicious URL with some malicious contents. So they were able to overwrite the WordPress theme PHP file. Then this PHP, once this PHP file landed into the container, right? Not necessarily in the storage, it could be in the memory. And then whenever anybody browse the homepage of this WordPress, it will launch the malware inside the container. So it's a process inside the container get launched, and then it creates a secret back channel back to the hacker. Of course, it's encrypted, so you won't see anything abnormal from the gateway firewall or AWS firewall. And then the hacker think, okay, I got everything launched and linked. So after like 2-3 days, because we keep tracking them, we see this guy trying to do a slow loris DDoS attack from this container all the way go to his target, which is in Poland. And at this point, we have to do something because we cannot use our container to attack, right, the Poland environment. So we stopped that DDoS attack right away because the NeuVector was protecting all the networking there. Then at the same time, hacker realized that because one of his attack failed, didn't get through. So he knew he was in the trap. So interesting enough, the second day, he was in initial tons of ICMP flooding traffic goes to our honeypot. At this moment, AWS finally realized that that attack and sent an alert, but that's also too late because NeuVector already sees those ICMP flooding attacks. We capture all the forensic, we block all the traffics. The beauty is at the same time, NeuVector, this WordPress web server, still running healthy because we cherry pick and block all the bad traffic, but the good traffic still goes through. So this is an interesting, case. You can see from end to end, a hack into the container and use container as a stepping stone to do more bad things, and how we protect, and trap them. So the last case I want to tell is it's also happened actually only 1 month ago or something. I think you may see that some programmer realized that open source SSH library, I think it's a Python library, have backdoors built in. That backdoor is a bad function. It's sending the user credential back to a URL, do a HTTP post. The issue is this open source library is heavily used by a lot of other libraries because the layers and layers of open source, and it's being installed more than 1 million times over years, right? So until today, recently, a month ago, they find this issue, and then it's already spread out, widely spread out. After that, the original programmer was noticed and removed this whole library off the GitHub. So that's a typical SSH, open source backdoors. Also, the same thing happened quickly. I think 2 weeks ago, 3 weeks ago, right? 17 backdoored malicious containers was removed from Docker Hub because security researchers found they have all kinds of security issues there. For example, those containers include the MySQL container, Tomcat container, and they have a Python reverse shell built in. They have some Bash reverse shell. They even have a crypto mining software there. It just sits in the container. All the scanning tools, it just cannot find it because it's open source and they build it. They generate the new binaries. You don't have a signature. The signature-based solution will help, but cannot really address those hidden backdoors efficiently. So I also saw some reports, newspapers says more than $30 million Bitcoins, was stolen by some incidents happening in Korea. So those are the issues happen today a lot in the public cloud or private cloud, especially in the containerized environment. So we believe you can see with the new changes of the container platform, with the new change of all the security issues and the attack angles, it came from multiple angles, came from multiple directions. So we believe to protect, give you efficient runtime protection on the container environment, you need to have a solution that be able to detect also from different angles and different checkpoints. So you need to be able to a solution be able to tell the kill chain events and chain them together. That's why NeuVector have this multi-vector detection, multi-vector firewall. We actually do have multiple layers of protection. We do network inspection, container inside inspection, host security as well. So from all the different angles, processes, memory, CPU, file system, networking, application awareness, all things together, correlate them together, we were able to give you a good presentation of the kill chain. You have good visibility around your environment, and at the same time, you gain multiple checkpoints from multiple vector detection. So I mean, let's look at the security issue from a different angle, right? So what's the best practice for secure your Kubernetes platform? We think you can separate that into three basic layers. So the layer one security is gonna be something like, yes, when you build a container, your developers should have this image scanned, right? There are tons of scanning solutions in the market. NeuVector also provide that. And also, if you have the Docker Enterprise or OpenShift or Rancher, you may have some basic scanning solution already there, right? Also, if you can do better, more work on that, you can do digital sign on your containers. That's a really good practice you want to have. Then the second layer of security is about hardening and protect your platforms. For example, you want to do a check all your Docker hosts, right? All your container hosts, make sure there's no critical issues, no CVEs. And you want to define the good access control policies came from Kubernetes or all the orchestration system. And you want to do the orchestration security. You want to give the strong password, right? Not like Tesla's case, you cannot use default password. And also they provide the layer 3 network segmentation, right? The basic segmentation, like Murali also mentioned about network policy. If you have those Kubernetes platform there, you want to use those basic platform securities there. That give you a good foundation to run your containers. So other than those two layers, we believe you do need a third layer, which is super important for the runtime security. Because your container get built, get tested, and checked in maybe only a couple of weeks. But when you run this service in your real workload in cloud, it could be months or years, keep updating, never stop. So that's really a long period of time you have attacking surfaces open there. So a good runtime security can give you a really deep layer 7 network security, like NeuVector did, because it has to be very application-centric, application awareness, not only about port and IP address, because port and IP address doesn't make sense anymore in this virtualized environment. As Murali also mentioned, it's super dynamic. It's keep changing. And you want to have a security solution be able to automatic discover and protect those systems. You cannot, the manual firewall rules just doesn't work anymore. Also, not only network, we believe the network is the most efficient way to protect you from outside of a container, right? It has to be in place. But also, another angle of the protection came from insider threats. So you need, for example, the bad containers, the backdoor containers. So you want to have a strong endpoint security as well, which means you want to have a solution be able to take care both inside and outside of the container, also correlate them together, give you a strong, protection around those. For example, data stealing, 0-day, also the crypto mining, all those kind of security risks. So the NeuVector's unique solution is we are super strong at the runtime protection. We are leader of the multi-vector firewall solution. So the solution itself is super lightweight. It's pure containerized, which means you don't really need an agent, because in this microservice world, you don't want to open the container install the agent inside the container, it's just not right? It's debate. It's not the right way to do the microservice at all. Also, if you have a agent on a VM, it cannot see, it's blind to your container environment. It's a virtualization layer on top. And that's why NeuVector invented this containerized runtime strong protection. And we do auditing and compliance check before you go production. So we do the CIS benchmark, Kubernetes CIS benchmark, Docker benchmark. We also do retro scanning, Jenkins plugin to help you developers to do the basic base layer security protection. And some platform like RBAC integration, right? Those give you a good, together with platform orchestration like Rancher, give you a good second layer protection. On top of those two layers, then you have strong runtime protection. The beauty is we automatically built in the knowledges about all kinds of popular threats. Those are especially the ones targeting the containers and Kubernetes. And yeah, we also do the deep layer 7 analysis and do the endpoint security. For example, monitoring the syscalls, monitoring the processes, and also the file systems. Beauty is everything happens automatically. So you gain the visibility and the security in the automatic fashion. Of course, for the response side, NeuVector could do the alert block or even quarantine your containers based on the behavior. And we can even do the packet capturing for forensic or for troubleshooting. It's super unique and strong features around that. So the last slide I want to quickly talk about on top of Rancher and Kubernetes. So what's the main thing NeuVector what's the value added, right? It's really about real layer 7 deep network security and the deep network security, and then compliance and response. Those are the spaces I'm trying to say that it's really critical for your overall security practice, because that's your service is running 24/7 and for years or for months. That's really the long period of time you want to have a protection around that to avoid those Tesla, the backdoor container, all those, mistake, all those real, security issues. So thanks everyone. That's my presentation today. Now I hand back to the host.
Thank you. That was very interesting. Again, thank you, Murali and Fei. So now I'll open up for Q&A. So please write your questions in the chat box. Okay, so the question is, how do I deploy Rancher and how do I deploy NeuVector?
So let me share my screen. Could you please pass the ball? I'll quickly go over that question.
Okay.
Okay, so to deploy Rancher, you could just go to docs.rancher.com, and here we have an installation section, like where there are different options to install it. The simplest one to try it out on a single node is a single command here. So this is the simple command to run Rancher setup. And once you have Rancher, to install NeuVector, so we have docs.neuvector.com port 3080, and here there are installation options. And if you're planning to deploy into production, for example, here we can see the Kubernetes production deployment, and this lists out how to create namespaces, how to create the secret, the cluster role and cluster role bindings, and the actual YAML to start the various components that are needed to start playing with the NeuVector. Now, for sample purposes, for example purposes, I have, so this is the Rancher interface. So once you install Rancher, you could see the various Kubernetes clusters that you are managing here. So I have one cluster created, and here what I did was I created a project called NeuVector, and inside this project I have deployed the NeuVector application. So I basically took this YAML file and went into Rancher. Like for example, I have this cluster here, right? So I could open up kubectl, and here I create kubectl create -f, and then I specify the YAML file NeuVector.yaml file, which has all the contents from this page. And let's just quickly take a look at NeuVector. So if I click on this node port, so I think I have some technical difficulties here. Some
HTTPS, yeah.
Oh, HTTPS. Okay, got it. Oh, cool. So here is the
everything needs to be secure.
yeah.
Always.
Okay.
Yeah,
So this is how the dashboard looks like. So here we can see, what are the security events and how many containers we have and what are the CVEs and stuff. So here, the interesting thing that I wanted to quickly show you was this network activity. So, here after deploying NeuVector, after a few minutes, it learns the topologies of, the various applications. So here in my cluster, I have a different project where I have deployed a WordPress application. So here in NeuVector, if I zoom in here we can see, the WordPress pod, and we can see the, the MariaDB pod, and you can see the direction in which the communication is happening. Here you can see the WordPress is initiating connections to the WordPress in this, the line with that direction. And we can see the various other communications that are happening within the Kubernetes components itself. There are like these hosts and stuff like that. And some of these red lines, they kind of indicate some of the traffic that was seen after the NeuVector has started, like it finished its learning, like something is abnormal. So you could take a look at what's going on and stuff like that. And there are like a lot of functionalities available here in NeuVector as well. So that's a kind of a high level overview of how the Rancher UI looks like and the NeuVector UI looks like. And to summarize, you have the Rancher documentation as well as the NeuVector documentation to install Rancher as well as NeuVector.
Okay, thank you,
Yeah.
Murali. Okay, so the next question is, what is the industry standard hardening used by NeuVector?
So NeuVector support the CIS benchmark scanning, the Docker benchmark, and the Kubernetes benchmark. We even open source, I think, Kubernetes benchmark in GitHub. And also there's some industry standards like NIST, right? Those are very general security practices. There's no specific spec for container spaces. So, but NeuVector's container side security reports can be part of your whole NIST or security standard reports. So those are all compatible and being supported.
Okay. And then another one for you, Fei, is can you provide more details for how your honeypot was set up?
Sure. The honeypot I showed in the demo is really running on the AWS environment. Basically, you can run on the ECS or EKS or the EC2 directly. You deploy Rancher or Kubernetes. That doesn't really matter. So what I did is we have our NeuVector as a container deployed on top of the AWS environment, and we have Kubernetes as a base layer. Then we deploy a couple of application containers, like I showed. We have WordPress, right? The database, just typical 3-tier web applications, several. I mean, 10 or 50 containers there. Then you put a NeuVector in the auto learning, then protect mode. Then just waiting, see every day you can see some activities there, and you will see some hackers trying to get in almost every couple of days.
Okay, and then this one is for Murali. Which Kubernetes is compatible with Linux servers and Windows servers?
So So Rancher supports all the upstream Kubernetes. Like we try to keep up with the upstream Kubernetes releases. Unless needed, we don't patch the upstream Kubernetes. So Rancher supports all the upstream Kubernetes, so that whatever support is provided by the upstream, we provide the same thing. So that's the support that we have.
Okay, thank you. And then Fei, is there a free trial or how is NeuVector priced?
Yes, we have a free trial version. Feel free to submit from our website or contact any of us. You can get a free trial version. It's as I said, it's container based. It's pure containers, super easy to use, and it's not. I want to mention it's not a SaaS service. You don't really need our secure solution talk to the cloud. That's a potential another attacking surface, right? So you can purely own that container privately and protect your system. About the pricing, right? What's the other question?
About just the pricing and if there's a free trial.
Yeah, okay. So pricing is we charge, listing price is we charge per Docker host per year. But we're happy to work with you if you have any special requirements. Our sales team, I can link to the sales team to work with you.
So we do have many more questions, but we are hitting the top of the hour. So we'll go ahead and follow up on these questions with answers. But again, all of these questions are great. And some last minute items to mention. We've added the Rancher 2.0 flyer and the NeuVector data sheet for your reference. This webinar was recorded, so a follow-up email with the recording will be sent to you shortly after this webinar. So maybe we can answer one more question before we close off on the webinar. And this one is to you, Murali, is how to set up Rancher in GKE.
Okay, that's an interesting question. So we have if you go to our Rancher UI, so in the global page, so we have the add cluster option. So here we have an option called GKE here. So you just select it and provide your service account details. And once you provide the service account details, you can choose the networking and some other cluster options, and you just configure the nodes there, and you click next. You are done with it. So that's how you would create a Kubernetes cluster in GKE. But if you are looking to set up the control plane itself in GKE, I think there are some instructions here. It all depends on how you want to set up. Is it a single node or is it a HA? Where are your certificates coming from and things like that. So there is a lot of information available in the installation guide here, and using that you can figure it out. Or if you have any more questions, please feel free to reach out to me on either Twitter or Slack, or you can reach out to us on our Slack. It's slack.rancher.io.
Okay, great. So I'll go ahead and end the webinar now. And again, thank you everyone and have a wonderful day.
Thank you.
Thank you.